Hello friends, I am Priyatosh. Welcome to your very own channel that is Not So Tech. My previous video was on blockchains, the technology powering cryptocurrencies like Bitcoin. In case you wish to know a little bit more about blockchains in simple language, then please do watch the video. Click on the link appearing on top right now. Do share and subscribe to my channel for more videos to understand stuff that is not so tech. Bitcoin mining is the process to release new bitcoins into circulation by way of rewarding bitcoins to a successful miner. It is akin to gold mining in the sense that gold is extracted from earth after tedious digging. But in essence, there are no physical coins or currency notes of Bitcoin. It's all software, programming, and algorithm. So what actual steps does a miner take to get rewarded? First of all, picking up transactions from the transaction pool and building a complete block by taking all of the necessary inputs as per Bitcoin protocol. Validating the transactions. It is easy because a common chain of entire transactions is available to every miner where the validity of transactions can be verified. Proof of work, which involves generating hash for the block, comparing with the target hash. If not equal or less than target hash, then increment the counter and repeat this step. In my opinion, it is more like throwing of a dice. Now, generating a hash and entire proof of work that many say is like solving a difficult math problem. If winning hash is found, then it has to be announced to all the participating nodes for verification, and the reward is sanctioned to the winning node. Now let us explore the concept of proof of work with a game of dice analogy. Let us set a target cap of 12. Player's aim is to throw dice and get rewarded if face value of dice is less than 12. As you may guess, there is hardly any difficulty in getting rewarded as the probability of winning is high. Only one of the dice should have face value less than 6 and the player wins a reward. If everybody agrees to the dice value, it is known as consensus. All the details are noted in the ledger, which is called ledger updation, and the player is ultimately rewarded. Now let us reduce the target cap to say 10. Now this just increased the difficulty. Why? Because outcomes like 6-6, 6-5, 5-6 and 5-5 are now non-winning throws. Reducing the target increases the difficulty. Finally, the target with highest difficulty is the lowest possible dice value of 1-1, that is a total of 2. This is how the proof of work concept works. The lower the target hash, more difficult it is to guess, more the iterations to get a winning hash. Now let me explain the guessing part a little bit more. You may have come across all the explanations regarding the guessing part. We know that hash function is a one-way algorithm that, given a particular string of data, will always produce the same output consistently. However, given the output, it is just not possible to figure out the input data. To illustrate, please take out your calculator and get the square root of 2. Our hash output is 9 digit starting from 6th digit after decimal. This is a not so good approximation of hash function, but we are easily able to get a consistent output from a defined input, and apparently output has no clue about the input. Try this with numbers 3, 7, 11, 13 and any other prime number. As you may have guessed, I am using prime numbers. Now suppose I tell you that my winning hash starts with a 15. Guess the square root of the number. What will you do now? Resort to finding square root of prime numbers after 19? Now that's so simple. Why will somebody pay you for something that simple? But what if I was to tell you that I have a target hash starting with 5 zeros? Now find a square root that will give you a hash less than my target hash. There you have difficulty and scarcity of output. Now actual mining involves SHA-256 algorithm. Transactions as input are known. Now the hash generated should meet certain conditions to win a new block. It should be less than or equal to the target hash. But with mixed set of transaction data, the output hash will always remain the same. So miners must append a counter called nonce to transaction data to get a different hash every time. And if the resulting hash is still not meeting target condition, then the miner again tries with a different or incremented nonce. Let us, from our mining machine, try for an output hash with 2 leading zeros. We increment our serial by 1 every time a new input is fed. We observe that serial 00020 gives us the required hash output. In the chart displayed below, the target is starting with 007. Entry hash 1 and hash 3 are rejected because even though they start with 2 leading zeros, the third digit is higher compared to the target. Entry hash 2 is the winner. Now just imagine this process repeating trillions of times. That's actual Bitcoin mining and solving the puzzle. Now how profitable is Bitcoin mining as on September 2018? Consider these facts. Bad news. More than 82% Bitcoins are already mined. Well, good news one. About 3.78 million Bitcoins remain to be mined. And the reward for a winning block is lucrative. Hey, bad news too. Rewards are halved about every 4 years. Next halving of rewards from 12.5 to 6.25 Bitcoins is due in 2020. So, more work for lesser reward. In any case, probability of finding a winning hash is less than 1 in 7 trillion. So the verdict? Solo mining is ruled out unless you have a system with petahashes per second computing power in place. Try pool mining. Initially, only a standalone computer was sufficient to mine Bitcoins. But as more and more mining happened, the difficulty increased and soon single processor systems were no more sufficient for mining. Low-cost GPUs were soon deployed into mining rigs as it was found that GPUs were more suitable for crunching hash functions. However, with ever-increasing difficulty, as more and more miners joined, ASICs or application-specific integrated circuits with very high hashing rates came into picture. As of now, at the end of Q2 2018, probability of finding a winning hash is less than 1 in 7 trillion, which is too high to achieve profitability for individual systems. Bitcoin rewards are paid to the miner who finds the winning hash first. Miners with mega hash or gigahash per second mining power stand a very little chance of winning a block on their own. Hence, they join groups of miners in what is known as a mining pool. It is collective computing operated by businesses that coordinate groups of miners. By working collectively and sharing the payouts, miners can look forward to incremental income with not so high-end equipment. Many times your own hardware, software, electricity bill, heat, noise, efforts and fast-changing mining scenario, mining Bitcoins is just not worth it. In any case, if you still wish to mine Bitcoins, then you may choose cloud mining. Cloud mining utilizes the processing power of third-party data centers. Mining can be hosted, which means mining is on hardware hosted by data center. Or mining could be virtual, meaning creating a virtual server and installing your own software for mining. Or it could be leased hashing power, which just borrows hashing power from the data center without having a dedicated physical or virtual computer. Well, a holistic view of mining process in flowchart for understanding purposes only. And I would like you to comment in what way can I improve this flow diagram. And for those of you who wish to know the differences between cryptocurrency and fiat currency, I have compiled a few differences. Please have a look. Thanks for watching. Till we meet again, take care. Bye-bye.